Welcome back to Calculus Fun, and today we're going to be talking about the second derivative test. So previously we saw how to find maxima and minima using the first derivative test. Now the second derivative test makes this semi-easier. So there's conditions to use this test like any other test, like the intermediate value theorem or the first derivative test. So the conditions to use this test is that the function must be twice differentiable, and the first derivative at some point must be equal to 0. And then if a critical point, or if the second derivative of the x value of the critical point equals 0, then we consider the result inconclusive. If the second derivative of the critical point, or the x value of the critical point, is less than 0, then there is a local maximum, and if it's vice versa, or the opposite, then we have a local minimum. With that out of the way, let's use this to practice. So for the first function, we're given f of x is equal to x to the fourth minus 4x squared. So the first things first is we're going to want to find the critical points. So it's going to do f prime of x is equal to 4x cubed minus 8x. Then to find the critical points, we're going to set that equal to 0. And then we will solve. So we'll take out 4x with x squared minus 2. So we'll get x equals 0, and then plus or minus the square root of 2. Okay, then we're going to take the second derivative. So it's going to be f double prime of x is equal to 12x squared minus 8. So let's do this. So we'll do f double prime of 0 is equal to, 12 times 0 squared is 0, minus 8 is negative 8. So since the second derivative at x equals 0 is negative, this is a local maximum. So we can conclude that first. So then we will do negative root 2 and positive root 2. So f double prime of, let's do positive root 2 first, is, root 2 squared is 2. So 12 times 2 is 24, minus 8 is 16. Then and since the squared gets rid of the minus sign, we're going to have the same outcome for negative root 2, which is also going to be equal to 16. So these are both local minima. All right, so let's move on to the next one. So now it's not a polynomial, and now we have a polynomial mixed in with a periodic function. So first things first, we'll try to get the critical points. We're going to take the derivative first, which is equal to 1 plus 2 cosine of 2x. So after we took the first derivative to find the critical points, we have 1 plus 2 cosine of x. So we'll set that equal to 0. It's 1 plus 2 cosine of 2x is equal to 0. Then we'll have cosine of 2x is equal to negative 1/2. And then in order to make this easier, we'll do let u equal to 2x. So we can place u in place of 2x inside the cosine. So you do cosine of u is equal to negative 1/2, and we're doing this from 0 to 2 pi. So we'll have u is equal to 2 pi thirds, 4 pi thirds, and that will be it. So, but then we still have the u is equal to 2x, so 2x is equal to 2 pi thirds, and it's also equal to 4 pi thirds. So we'll do x is equal to 2 pi over 6, which is equal to pi thirds. And then x is equal to 4 pi over 6, which is 2 pi thirds. Okay? So then I'm going to want to take the second derivative to check it out. So what I'm going to do is I'm going to do g double prime of x is going to equal negative 4 sine of 2x. And then we'll plug in the x values that we found right here. Then we'll plug them in. So we'll do g double prime of pi thirds is going to be, let's see, -4 sine of 2 pi thirds. I already know that sine of 2 pi thirds is positive. So since this is going to be a negative, because a negative times a positive is a negative, this is going to be a local maximum. And if we do g double prime of 2 pi thirds, it's going to be -4 sine of 4 pi thirds. And since sine of 4 pi thirds is indeed negative, and a negative times a negative is a positive, it's going to be a local minimum. All right, last but not least, we have an entirely non-linear function, or non-polynomial function, which we will take the derivative of. So for number 3, we have f of x is equal to ln of x squared plus 1. And then we're going to take the derivative of that to find the critical points. So we do f prime of x is equal to, it's going to be 2x over 1 plus x squared by the chain rule. So then we want, and then we're going to set this equal to 0. So it's going to be 2x over 1 plus x squared is equal to 0. We don't have to add any restrictions to the bottom because our restrictions would be the imaginary number I. So, and that doesn't matter because in calculus we work in real numbers, at least for right now. So it's going to be 2x is equal to 0 and x is equal to 0. So all we have to do is check 0. Okay, now we're going to have to do the second derivative of f, or second derivative of f, or the derivative of f prime. So f double prime of x, remember we did low d high, so the derivative of the high, so it's 2 minus high d low, which would be 2x. And then we'll do square the low. All right, and then we'll simplify the top to make the calculation easier. So we'll do 2 plus 2x squared minus 4x squared. Then we'll keep the bottom the same. And then we'll have 2 minus 2x squared over 1 plus x squared. And then we can simplify this. Well, we can't simplify this anymore. All right, so we'll call that f prime. So now we'll do f double prime of 0 to check. We'll have 2, right? Because 2 minus 0 squared is 0 over 1 plus 0 squared, and 1 squared is 1. This is 2, and since 2 is positive, this is a local minimum. I hope you learned something new today about the second derivative test, and I hope I'll see you next week.